All right, we're going to finish up 6.7. 6.7. Last three slides of 6.7. It is dying, guys. It is dying. I didn't hear almost at all trick or treating. All right. You invest money in stock at 6% interest. But compounded monthly. That's wild, actually. How much until your investment doubles? How long until it triples? All right. Mike's on. They hit record. I'm not all with it today. All right. So our equation for this piece is what? Amount equals my principal, 1 plus my rate over, what letter did we use for number of times compounded? What did we use for these notes for number of times compounded? Every book's a little bit different. I just want to make sure I give you M. M to the M T, right? Whenever it's not continuous, that's the formula I'm going to use. And this one's not continuous. So let's turn into a real formula. Do I know how much I started with? Does it give me a starting amount? No, so I'm going to keep that as P for right now because I don't know. Do I have a rate? I do. 6%. And monthly, how many times a year does a month happen? 12. All right, so that's my formula I'm going to be working with today. All right. Now, how long till your investment doubles? They never gave me a starting amount. What if I start with $1? Could I use that? Would my doubling time of $1 be the same as $1,000? It will be. It will be. That's good investment advice. All right. $1 saved will be $2 in like 10 years. All right. So I'm going to use the formula 2 equals 1 times. Do y'all want to deal with this in your calculator, or can we convert that into just one simple number, one less complex number? Yeah, let's convert it. Like, all right, so that's 1.005. If you're wondering where this number came from. All right, to the 12t. Because what am I solving for? I'm solving for how long. Whenever the question is how long or how much time, we're always solving for the t. All right. Ta-da. I'm not going to worry about that one. You could have written the one in there. That's fine. What do I do from here? Do you guys remember? Isolate. So quick reminder, you ISO the exponential. And then what's always your next step once it's by itself? You're going to log both sides every time. And then third, it's algebra time because everything's a number. Okay? Algebra Tim. Who's Algebra Tim? I guess it's someone who's short in time would be Tim. Is it? All right, what do I do to both sides? Is my exponential by itself? Yeah. So I'm going to log both sides. Natural log of 2 equals natural log of 1.005. And when I log it, what do I do with this beast? Move in front. That's the new step, right? That's the new step. Now what do I do? Look at my notes. Yeah, divide. I can divide them both by. Can I divide them both by 12 and natural log of 1.055? You know what I mean? Because I need to get that t by itself, and these are both multiplying, right? So I get t equals whatever this absolute mess is. Hold on. I wrote that wrong. That should be a 2. Yarnar. That was a lot. I got 11.58 years. Yarnar. It's a lot for a Monday morning. That's a terrible choice. All right. So if I want to know how long till, what is this? That's one of those fat cats. How long until it triples? What am I going to set this equation equal to this time? What would I set this equal to? How long until $1 becomes 3? All right. Pause the video. So you guys can do this stuff. All right. Natural log both sides. 12t times natural log of 1.005 equals natural log of 3. The only thing to be careful of that I didn't really talk about is when you do this division, if you're doing it all at once, make sure when you plug in your calculator, you're putting the whole bottom in parentheses, because if you don't, you're dividing it by 12, then timesing it by natural log of 1.005. Okay? All right. What did you guys get? 18.6? 5 something? 36? I'll believe you. There we go. If you can do that, you can do like a quarter of this test. It is actually. I might go rapid fire to the next two because it's the exact same problem as we just did those two, just slightly different. We did. We're finishing up this section. Yeah, we're going to do it again too in 6.8. It's pretty much the main meat and potatoes of this section is solving exponentials and logs. All right. If you invest $400, how long until you have $2,100 from the previous one? So this 2,100, that's our total amount, right? That's going to be our A we plug into the formula. The 400 is our principal, our starting amount, okay? So now we aren't doing doubling or tripling. We're just plugging in our P and our A, and we see what happens. So we look at our original equation, which is written up on your guys' like slide above or the other page. 2,100 equals 400 times 1.005 to the 12t, right? Now this one, what do I have to do before I start? What's my first step on this one? I can't just log both sides. What do you have to do first? Yep, you got to divide by 400. Get this by itself. Let's see if I can do that in my head. That's what, 5.25? Yar? And then from there we do what we just did. Natural log both sides. Move the 12t in front. I'm losing my voice. Yar or nar? How do you guys feel about basic logs? If I just had basic logs, do you guys feel content? Divide by my 12 natural log, 1.005. And t is approximately 27.71 years. Yars. What's I gonna say? I do want you guys to realize though, I know I've said this a lot. Think about if you plan on working a job for like 30 to 35 years, if you invest $400 on that first day you start working, by the time you retire, you'll have even more than $2,100 from that 400, right? Every dollar you invest your first year working will pretty much quadruple to quintuple by the time you retire. You will. The market average is 8 to 10%. No, yearly. They're taking that and compounding it. No, you will. That is accurate. You will about quadruple to quintuple your money that you invest your first year working. By the time you retire, it will. That's why you know what I mean, make good investments when you're younger. It'll definitely pay off in the long run. And if you put it in a bank, you get 0.035% instead of 6 to 10%. You know what I mean? So anyway, I digress. So keep that in mind when you guys first start getting jobs. Roth IRAs, 401s, like all that stuff, do it. I wish I put more into mind when I first started. I knew more about it because it would have grown exponentially. And it's pre-tax, so you don't have to pay taxes on it until it comes out. I digress. Last example is 6-7, and then we're going to do 6-8, pretty much like that. I made my own little packet for it. You're going to invest in a company that's growth is compounding continuously. The growth rate is 5%. All right, if it's continuous, this is a good review. We're using PERT, E to the RT, right? PERT. You have to memorize all those? No. Just make sure remember the first few pages of 6-7. There's a bunch of different formulas. All right, so if I invest doubling, whenever I see doubling time, how much money do you want to start with when you do the equation? $1, right? Makes it easier. So how long will my $1 take? Where's my growth rate? 5%? How long will it take my $1 to become $2? All right, these ones are even easier, aren't they? Because how do I get rid of e's? How do you get rid of an e? You natural log both sides. And then these will just straight up cancel, right? So you get natural log of 2. Yar. So remember, when you see the e's, use a natural log. It'll go away. Divide by 0.05. I ran out of room. And t will be approximately 13.86. Yars. All right. Go ahead and pause the video. You guys try that one. Try the second part. Give it a shot. All right, for doubling time, I do my 2 and my 1. And all I changed was my rate. Yar? Oh, wait. Why did I write natural log there? Oopsie doodles. It's been a long life. Then we natural log both sides. I'm skipping some steps here. What did you guys get? I got a goofy t equals approximately 6.93. That's pretty good. It's pretty good doubling time, which is about what the SYP does, around 10%. All right, good talk. All right, I'm actually going to stop this one. All right, that's